Hi guys, this is the video for some extra support with some of the concepts that you're doing in this writing linear equations review. So if you need to look at any of the sections for some notes, we're going to do those here. So if you want to look at finding the slope, I'm going to do some notes right here. You can look at it with me and hopefully that will help you find out these problems down here. If you don't need to do this, go ahead and skip ahead in the video to the section that you need and you can have some review from that and hopefully that will get you to where you need to be in terms of answering the questions on your own. So for finding slope. Slope, when we're looking at an equation like this, you can see the slope from right here. The slope is the m. In this case, our slope is what's in front of the x. The slope, the m, is just 2/3 from this one. And there we go. Well, that's kind of a bright marker. I might try a different one. Let's see if this works better. So in this case, there wasn't anything you needed to do, but recognize that the slope is the m when it's written as y equals mx plus b. If we're given two ordered pairs like this, we actually have to calculate the slope. So the slope is the change in y over the change in x. And to find the change in y, these are the y coordinates right here. We do y minus y on the top, -1 minus -2, and x minus x on the bottom, 4 minus 2. The change in y over the change in x, and then we just calculate this very carefully and pay attention to our negatives. Minus a negative becomes plus a positive. You add the opposite. And -1 plus 2 brings us all the way up to +1. 4 minus 2 is 2. So in this case, our slope is 1/2. If we had had a negative number in one of those, then it would have been a negative divided by a positive. It would have made the whole thing negative. So if you end up with a negative, be careful, make sure you simplify to make the whole thing negative. So now, using that, you're going to do these questions on your own. Y minus y over x minus x, and simplify. Number 3 is similar. Y minus y over x minus x, and simplify. This one, you can see the m already. Okay, on to the next section. If you need to learn how to write equations in slope-intercept form. So slope-intercept form over here is y equals mx plus b, and the m is the slope, and the b is the y-intercept, where it hits the y-axis. So from here, we are going to see what we need to do to plug in to y equals mx plus b. We need y equals mx plus b. Do we know the slope? Do we know the m? Yeah, it's 6. Woohoo! We can put that in there. Do we know the b? Do we know the y-intercept? No. If this was like 0, -2, it would be a y-intercept, but 2, -2 is just another point. So we don't know the b. The b is still an unknown. We've got to figure out the b, and we're going to use this information right here to do it. We know that this is just some x, y, some ordered pair that point goes through. We're going to take our x and plug it in for this. Take our y and plug it in for this y. So our 2 is our x. We're going to plug in there. This -2 is a y. We're going to plug it in for that y. So it looks like -2 equals 6 times our x is 2 plus b. -2 equals, now that's just 12 plus b. And now can we get that b by itself? Yeah, subtract 12 from both sides. Be really careful here with your negatives. -2 minus another 12 takes you all the way down to -14. So we get that b equals -14. So now we knew our m was 6, and now we have our b, y equals 6x plus -14. And we're done. We've written it in y equals mx plus b. Let's try this guy. We want y equals mx plus b. Now, these over here really just stand for ordered pairs, don't they? 10 is your input. F of 10 equals 5. There's your input, and 5 is your output. This really just stands for 10, 5. And this really stands for an input of 5 gives you an output of 0. So those are two ordered pairs. Do we know our m? Does it tell us our slope? Nope. So we've got to find it out. We've got to do y minus y over x minus x. 5 over 1, or 5 minus 0, 5 minus 0 over 10 minus 5. What is 5 minus 0? 5. What is 10 minus 5? 5. 5 divided by 5 is just 1. What was that? What were we finding? Yep, that was our slope. So we're going to plug that in right here for m. Our slope is 1. Do we know our y-intercept? Do we know 0, comma something where it hits the y-axis? No. 5, comma 0 would be side to side 5, up and down 0. That's an x-intercept. That's not a y-intercept. So we don't know the y-intercept yet. That means we've got to do the same thing as last time. We've got to take one of these x's and y's and plug them in right here. You can pick, though, this time, either one. It doesn't matter which ordered pair you pick. I think I'm going to pick this guy just because there's a 0 in there, and sometimes that makes things easier. We'll see whether it does in this case. I'm going to put in 5 for x and 0 for y because that is an x, comma y. So 0 equals 1 times 5 plus b. 0 equals 5 plus b, and to get the b by itself, subtract 5 from both sides. So I get negative 5 equals b. And if I had plugged in 10 and 5, I would have gotten the same thing. So you can pick any ordered pair. And now I know my m, my slope was 1, x plus, and my y-intercept is negative 5. There's my y equals mx plus b. So that should help you as you are doing the questions on the next page, doing number 4 and 5. Same strategies. All right, down here I don't have a note section for it, but I'll just review really quickly if you wanted to see how to do this. You start at the y-intercept to graph it, right? What's the slope here? The slope would be negative 1, and the y-intercept would be 4. So we'd start at our y-intercept, and we'd count our slope. Negative 1 would be like negative 1 over 1, so we go down 1 over 1, down 1 over 1. This would be our line with a slope of negative 1 that goes through 4. So I'll let you try 7 on your own. Okay, let's talk about equations for horizontal and vertical lines. This is one of the most recent things we've done. Horizontal lines always go through the y-axis because they're going side to side. So when given a point, the horizontal line is always going to be written as y equals. If you can picture where 3 comma negative 10 is, you go side to side 3 down to negative 10. Well, all the other points that are horizontal are going to go through y equals negative 10. Since that's the y equals negative 10. That's the horizontal line. Horizontal lines are always y equals. What's the y for this guy? X comma y over 4 up 2. So anything that's horizontal is always going to be over something and up 2. Our equation, y equals 2. Remember, horizontal lines have a slope of 0, so it's like 0x plus 2, 0x plus negative 10. Vertical lines are the opposite. Vertical lines go straight up and down, so you're always going to go side to side the same distance. So if you're always going side to side the same, how far are you going side to side? You're going to 3. You're going to x equals 3. Over here, side to side the same, you're going to x equals 4. So if I asked you for the horizontal and the vertical line that goes through points, I'll do number 8 with you. I want to know what horizontal line goes through this point, just like up here. Horizontal line was the y. Well, what does the y equal? Y equals 5. What vertical line, straight up and down, goes through there? How far would you have to go side to side? 4. So the horizontal line, y equals 5. The vertical line, x equals 4. And you just take them right from that ordered pair. There you go. You should be able to do 9 and 10 now on your own. Okay, next section, looking at standard form. Okay, so standard form of an equation, if you need to do the notes for this part. The equation would be ax plus by equals c for standard form. And just to remind yourself, to write an equivalent equation in standard form, we'd want to multiply or divide both sides of that equation by the same number. If your instruction said, give me an equivalent equation, an equal equation for this, pick something to multiply by. I don't know, what about 2? Multiply everything by 2. You could get 8x plus negative 10y equals 20. That would be an equivalent equation. Or you could multiply everything by 3, or multiply everything by 10, or divide everything by 2. As long as you're doing the same thing to both sides, you will make an equivalent equation. All right, now let's see if we can write equations in standard form on our own. The hint is going to be, I've got to change the instructions on here actually. Let's see. Identify the slope. Oh, no, I've got them right. We're going to write the equation in slope-intercept form, and then we're going to rewrite it in standard form. So the same thing we just did with the last notes for slope-intercept form, and then rewrite it. Can we write this in slope-intercept? Y equals mx plus b. All right, well, let's see. Do we know the m? Yep. The m, in this case, it even tells us flat out. It's 2. Do we know our b, our y-intercept? No, we just have another point. So we've got to take that point, that x and that y, and plug it in, plug it in. So the x, that 1 goes in for x, and the negative 1 goes in for y. Negative 1 equals 2 times 1 plus b. So that's really just 2 plus b. And I'm going to subtract 2 from both sides so that I can get that b all by itself over here. 2 minus 2 goes bye-bye. And careful, negative 1 minus 2 more is now negative 3. So I have my now y equals 2x plus negative 3. Am I done? I'm so close. That is in y equals mx plus b. That's in slope-intercept form. If I want it in standard form, I just have to rearrange it so it looks more like this. So my x comes first, then my y, then that equals a constant. So I need to get my x away from here. To get rid of my x, I subtract 2x. And let's see what we have left. Y minus 2x equals, this goes away. That was the whole point. Bye-bye. Equals negative 3. And I'm so close, I need my x first, and I can't just switch the order when it's subtraction. So I need to change it to adding the opposite. And now I can switch it around. Negative 2x plus y equals negative 3. That is in standard form. The x plus the y equals some constant there. All right, let's do one more in standard form so that you can have that example if you need it. This particular one gives us 2 ordered pairs. So this is going to be actually a little longer. It might take me some more space here. I didn't leave a lot of room. We've got to find the slope and the y-intercept for this. Y equals mx plus b. I don't know my slope. I got to find my slope. I've got to do y minus y over x minus x. So let's see. Negative 4 minus negative 2. Got to be careful here. Over then my x's, 2 minus 1. Okay, what is minus a negative? That becomes plus a positive. Add the opposite. And we get negative 2 over, let's see, 4. Negative 4 plus 2 is negative 2. 2 minus 1 is 1. I get my slope is negative 2. So now I know my y equals negative 2x, but I still don't know my b. So how do we find b when we don't know b? Yeah, we plug in, plug in. We take the x and the y and plug them in. Which x comma y do you want to use? This x comma y or this x comma y? It does not matter. It's totally up to you. I'm going to pick these just because their numbers are a little bit smaller. Maybe it'll be easier. So I'm going to plug 1 in for x and negative 2 in for y. Negative 2 times 1. So let's see what that looks like. Negative 2. So now I'm going to add 2 to both sides. Negative 2 plus 2 is what? 0. 0 equals b. So my y-intercept is 0. Just goes through the origin. I know that my slope is negative 2, and my y-intercept is 0. That is my y equals mx plus b. I need to turn that into standard form. So I need to get my x's over here. Well, this time, how would I get rid of negative 2x's? I'd have to just add 2x's. So I have y plus 2x. Could I just write that as 2x plus y? Yeah, because addition is commutative. It doesn't matter the order I write it when it's addition. These go bye-bye, and I just have equals 0. There is my standard form for this one. So now when you're trying 11 and 12 and 13, you've got to find the slope and you've got to find the y-intercept. Put it in slope-intercept form, y equals mx plus b. Then you've got to just rearrange it. Get rid of the x's to put them on the other side. And we've done an example with an equivalent equation like this one too. So you have all of those examples to look at now. All right, let's talk about writing equations. Okay, I'm actually going to go through and do this one. Even though it's not really notes, I'm going to walk you through at least how to start setting it up. A delivery service charges a base price of $5.95 for an overnight delivery of a package, plus an extra charge of $1.55 for each pound that the package weighs. We want an equation in slope-intercept form, so that's y equals mx plus b, that gives the total cost of shipping a package. So if it gives us the cost, that y is going to be the cost, because it's y equals, as a function of, as a result of the weight of the package. So our two variables, the thing that determines the cost is the weight. This x is going to be our weight, because depending on how much that is, it affects what the total cost is. So that's what our variables stand for. We just have to find the m and the b. So in this situation, our cost equals what? What happens with the weight? What does the weight affect? It's $1.55 per pound. So if it was 1 pound, it'd just be $1.55 times 1. If it was 2 pounds, $1.55 times 2. If it's X pounds, it's $1.55 times X. But then, plus this one charge, this base price of $5.95. So there's your equation. And all we have to know is how much it weighs, and we can plug that in, multiply it by 1.55, add $5.95, and it'll give us our cost. So now they're saying if you wanted to ship something that was 15 pounds, plug it in, and solve the equation from there. All right, you can finish that. Number 16, school board fundraiser. Students are selling seat cushions for $4 and license plate holders for $6. And a student raises $304. We want an equation in standard form, ax plus by equals c, of the line that models the possible combinations of seat cushions and license plate holders, that's a typo, the student sold. So how much did they sell total? $304. That's like our total. And we've got two variables. One's got to be for the seat cushions and one's got to be for the license plate holders. So how much was each seat cushion? $4. So depending on how many they sold, let's just put that here. $4 times X, and we're going to call that the seat cushions. Plus they sold license plate holders were $6. So each one was 6. If they sold Y of them, it would be 6 times Y. This is going to be the license plate holders. So depending on how many seat cushions and license plate holders they sold, we could plug those in, right? And it would give us $304. So how do we find out some combinations? If we know they sold $304, how would we find combinations? Well, what if they didn't sell any seat cushions? What if they sold 0 of those? Could you plug in X equals 0 and find out how many license plates they could have sold? Yep. What if they didn't sell any license plate holders? Plug in 0 there. Could you find out how many seat cushions they could sell? That would give you 2 possible combinations. So here's our equation in standard form. Remember what we talked about in class, that plugging in 0 is really just like finding the X and the Y intercepts for this. So what if it's 0 seat cushions? How many license plate holders? That's one combination. What if it's 0 license plate holders? How many seat cushions? That's a second combination that would work. So I'm going to let you finish that on your own. All right, and then for this last one, I think I'm going to start a new video that's just on parallel and perpendicular lines. So look for that one if you need these sets of notes.